are a little more tricky because now I have a coefficient in front of x squared, and that changes the dynamic of how I factor it dramatically. I'll show you an example, and you'll kind of see what I mean. As we walk through this, I'm going to show you two ways, sort of simultaneously, and then you choose which way you think is easiest. Choose whatever one works the best for you, and then just kind of ignore the other way. You don't have to know two ways to do it. I can tell you which way I think is easier, but I'll let you decide. The first way that I show you is how they do it in 4.3, and the second way that I show you is how they explain it in 4.4. I really like the 4.4 way, but we'll see what you think. What if I have something that has a number in front of r squared, like 3x squared plus 11x plus 6? To factor this, I used to be able to say it was x times x, right? Because that was the only way to get x squared, and that was simple. But now I have a 3 here, right? So to get 3x squared by multiplying first times first, I have to have a 3x and an x. It's still the only option, so I can still fill that in. It's just not guaranteed to be x and x. I have to think about what are the factors of 3. Because it's prime, it's 3 and 1. So that does help a little. And I'm lucky because this one is in both addition, right? So that's plus plus. So the only thing that's remaining is filling in this last thing. Well, the tricky part is, are there any factors of 6 that add to 11? 6 equals 1 times 6, or 2 times 3. 1 plus 6 equals 11? No. 2 plus 3? No. Neither one of those equal 11, right? So in the previous examples, we said all I had to do was find something that multiplies to 6 and adds to 11. But now, whatever thing I put right here is going to be amplified by multiplying times this 3. The outside pair is going to be 3 times something. And I have to decide, do I want to take 3 times a 1 and have a 6 here? Or do I want to take 3 times a 2 and have a 3 here? So there's lots of combinations. And this first method that they show you in 4.2 is essentially guess and check. I don't mind guess and check if there's only, like this case, 4 possible things, right? 1 and 6, or 6 and 1. With my other pair, maybe 2, 3, or switch them around 3, 2. That's only 4 things to try, and I'm okay trying 4 things, right? But sometimes my first term is not a 3, sometimes that's a 6. And I've got 2 possible pairings, right? And then sometimes this isn't a 6, sometimes it's a 24, right? Please, then I've got 1 and 24, 2 and 12, 6 and 4, 3 and 8, right? In both orders. That's a lot of possibilities to try. I'm not crazy about guess and check. If I have to try more than 5 or 6 things, that's a little tedious. I would probably prefer the second method. The second method has more steps, but each step takes you closer to the solution. And you know, when you walk through the extra steps, you are going to get to a solution. You're not going to get to a point that says, oh, that didn't work, try again. And when you do it this way, you will get to a point where you say, well, that one didn't work, cross that off the list. 6 and 1 doesn't work this way, 6 and 1 doesn't work that way, 2 and 3 doesn't work this way. Finally, maybe that last one will work. What would you like to try? Well, I tell you what, I don't think I want to put the 6 here, because what if I put 6 here and take it times 3? That's going to be 18, and I've already went too far, right?
So you're trying to get to 11.
I want to get to 11, but one of them has to be multiplied times 3. It's not just 6 plus 1 anymore, right? So let's pretend I put 6 here and 1 here. We'll just try it. If I put 6 here and 1 on the other side, then 6x is my inside pair, and my outside pair is 3x. Do those add to be 11? No. That's 9. So this guess was wrong. And we already ruled out switching the order, because if I switch the order and I put 1 here and 6 here, then I'd have 6 times 3, which is 18. I'm already too big. So this is a no. No, no, no. All bad. And we can cross this guy out. Next we could try 3 and 2. I was going to do that in color. Again, looking at this pair, putting it in some order, This is a 3x. This is a 3 times 2, that's a 6x. Does that work? Not quite, right? This is still 9x, not 11x. I have one more thing to try. Not 3 times 2. But we could try 2 here and 3 here. 2 times x is 2x, 3 times 3 is 9x, and if I add 9 plus 2, I get 11x. Ding, 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 we have a winner. Okay? But it's guess and check, guess and check. Choose your, figure out what your options are, choose one, plug it in, and see if it works. If it doesn't, try a different order or a different pair, and keep trying until you find one that works. And I've seen it happen that in this guess and check method, maybe somebody puts in the right answer, the right pairing in the right order, and then multiplies wrong, right? And they think, oh, that didn't work, so they cross it off, and they go through all the other solutions, and none of them work, right? Because somewhere along the line, the correct one was multiplied with a mistake, and you didn't see that it was the correct one. So my honest feeling is that while this follows the same process as we've done before, it can be a little frustrating. Let me show you the same problem a different way. If you remember back at the beginning of the night, we learned how to factor things that had 4 terms by grouping. So in this method, I'm going to rewrite it with 4 terms and then use grouping. Again, this method has extra steps. It's a little bit longer process, but I don't feel like I'm, running into a wall every time, trying and trying and trying. The process here says we're going to split the 11x into 2 terms. So instead of having one middle term, I'm going to split that into 2 terms. And the way that I decide how to split it is I'm looking for something that multiplies to 3 times 6, but adds to 11. So in my thought bubble, 3 times 6 equals 18. Then I ask myself, what adds to 11? I have 18 as my product. What multiplies to 18 but adds to 11? This is the same process that we did before, right? Exactly the same as we did before. So factors of 18 are 1 times 18, 2 times 9, 3 times 6. Which of these 3 pairings adds to 11? 2 and 9, right? So let's break this up as 2x plus 9x. Notice it doesn't matter if I put 2x and then 9 or if I switch it. You get a different in-between step, but you get the same final answer. Now I want to use my grouping. That means I'm going to put these 2 together and then these 2 together and ask myself, what do these 2 have in common? 3x squared plus 2x. Well, they don't have any numbers in common, but they both have an x that they could give up. So let's take the x off of both of those and put it out front. And that will leave me with 3x plus 2. And then on this pair, I ask myself, what does 9x and 6 have in common? What common factors do those 2 terms have? 3 is the number that goes into both of those, and that's the most that they have in common. So I factor off a 3. When I divide 9 by 3, I get 3x. 6 divided by 3 is 2. And then lo and behold, right? It works, it works. My parentheses are both 3x plus 2. So then I can say, well, if these are both the same, I can pull that off as a common factor, and then it's left with x plus 3. I get the same thing, 3x plus 2 and x plus 3. Let's go back one. Same answer, right? skipped a slide. But this, using the grouping method, I think is my preference because once I remember how to split this, then the rest is just chug to the answer, right? Chug, chug, chug. I have this extra step, but the whole way through I'm chugging to the answer, and I like that feeling. As opposed to this, where I go, well, that didn't work, right? Try this one, well, that didn't work. And the more you do, honestly, the better you get at guessing. You can guess right more quickly, because you can rule some out a little bit faster perhaps, but I actually kind of like the grouping method better. Let's do one more example, and we'll solve this one both ways as well. Factor (5x squared) plus 27x plus 10. You can either use guess and check, decide what multiplies to be 10, that would also add the 27 when one of them is multiplied times the 5. Or you can do the split out method to switch to grouping. Using the grouping method, I ask myself what multiplies to be the product of 5 times 10, multiplies to 50, but would add to 27. Multiplies to 50 and adds to 27. That's what I use as my when I split 27 into 2. Give you just a minute to do that. I'm going to get started using first the guess and check method, and then I'll solve it using the grouping method. With the guess and check method, I know that I have addition and addition. I love that. That means these are both plus. And my first term is 5x squared. 5 is prime. So although I'm not so lucky as to just have it be x and x, I am kind of fortunate that 5 is prime, so that it's x and 5x. I'm going to put the 5 out here, because that's how I did it on the last problem. 5x and x. It doesn't matter where you put the 5. I just thought we put the bigger number out here. Last time I'll do that the same way. And then I think to myself, what multiplies to be 10? Well, I have these choices, 1 times 10 or 10 times 1, and 2 times 5 or reverse the order, 5 times 2. Then you just start guessing. Well, I can probably rule out putting a 10 here, because if I put 10 here, 10 times 5 is going to be 50, and that's going to be way too big. I've already passed 27. So I know it won't be 1 and 10, but I could try 10 and 1. That would be 10x and 5x. That's a total of 15x. I didn't get there, right? I'm looking to get to 27. I didn't make it. So this guy's completely not going to work. Next, I might try 2 and 5. 2x, 5 times 5 is 25x. That works, right? I add those together and I get 27x. So this is indeed how it factors 5x plus 2 times x plus 5. Questions about this? Now, if you would have tried 2 and 5 first, you would have gotten it in one hit. And then that makes guess and check seem like the way easier method. If you can guess it correctly early in the process and only have 2 choices over here, 1 and 10, 2 and 5, then guess and check doesn't seem like such a bad deal. Now let's try the same problem using grouping. Again, ask yourself, what two numbers, multiply to equal 5 times 10, or 50, and add equal 27. Multiplies to this outside pair, 5 times 10, and adds to be 27. Well, 50 could be 25 times 2, and 25 and 2 add to 27. So once you hit on that, and you recognize, well, this is going to split to 25x plus 2x. 25 plus 2 does indeed equal 27. Then I just write the rest of this down. Then I go back to groups, and I say, what do these individual groups have in common that I can factor off? The first one has a 5 and an x that they both have in common, so I factor that off, and that leaves me with x plus 5. The second pair has a 2 in common. They both divide by 2, so I put the 2 out front, x plus 5. Now I recognize that my parentheses match. They have to match in order for this process to work. And that gives me x plus 5 times 5x plus 2. The 5x from here, and the 2 from here. And that's the same thing I got here, right? The hard part is hitting that 25 and 2. But there's, again, I feel like everything I'm doing, I'm working towards the one solution as opposed to guess and check, guess and check, guess and check.